Hello, today I'd like to discuss a little bit about why things float. And basically, it has to do with one way you could look at it is it has to do with density. If something is less dense than water, it's going to float. And if something is less dense than water, it's going to sink. And so, as you can remember, the volume, the density equation is mass over volume. And so, for example, right here, we took this like heavy metal. These boats are made out of these metals and a lot of this material that's quite heavy. And what's happening is if you just put it all, compressed it all in, and you didn't have a very large volume, but your mass was very big, it would sink. The other way to do it to make it to float is to create that same mass but change the volume. By making the volume larger, you're making the density less, and so therefore you will float on water. So it basically just has to do with density. If you could take this weight but distribute it over a large area, the density of it will then become much less than the density of water. And this works with anything basically. The other thing you can look at it, and it's indicated in this picture, is this thing called buoyant force and weight. So when you have the weight is more than the buoyant force, it will sink. Like it's in this picture, the weight is just too much compared to the buoyant force. But by changing that volume, I can make a larger buoyant force compared to my weight, and it will float. Now you might be asking, okay, how do you figure out what your buoyant force is? Well, it has to do with Archimedes. He was the guy, I remember, with the king wanted to know if his crown was made of gold or not. And he sat in a bathtub and water came out and he got this idea, eureka, and he figured out how to do it. Well, basically what Archimedes' principle is saying is the buoyant force is equal to the amount of water that you displace when you put something into water. So like right now, if I take this little bit of volume and I take this mass, whatever it is, and I put it in the water, and it displaces this much volume of water. Now if I take that, collect it, and weigh it, that weight will tell me how much the buoyant force is. How much will the water hold up? And in this case, the weight is much more than that buoyant force. But like I said earlier, by changing the volume, I can then displace a large amount of water. This large amount of water will weigh far more than what this boat is. As you know, water is quite heavy. Fill up a bucket full of water and try to lift it, it's quite heavy. And if you had this much water, that would be a large weight. So the weight of the boat, because a lot of it is empty space, is much smaller than the weight of this much water. And so that's why these big heavy boats, even though they're made out of metals and they have like steel in them and they're heavy, but because they displace a large amount of water, they have a large buoyant force compared to their weight, and they will still float.